Hello and welcome back to my channel Passion for Physics, and I'm here with yet another episode of Refractive Index where you will learn refraction through a glass slab. Okay, in this particular theory we will see that when a light ray passes from a glass slab, then it will try to shift sideways and emerge along a different path. Okay, and also in this video we will learn that what are the questions which are asked in CBSE examinations and how are we going to attempt those types of questions. So be in this video till the end and let's start with this video. So in this particular topic we have to first understand that what do you mean by glass slab. So glass slab is nothing but a 3D version of a rectangle. Like rectangle has length and breadth. If we include height, then it will become a cuboid, okay, which will have height also. Okay, so in such a shape, if we have a glass, then such a thing is known as glass slab. So in the board, we are able to draw only the two-dimensional glass slab. We are not able to draw the third dimension. So we will draw the length and the breadth of the glass slab, and this is your glass slab which is denoted by the vertices AB, CD. Okay, and these two sides, that is AB and CD, are parallel to each other. Once we see this glass slab, we can say that air has the refractive index Na and glass has the refractive index Ng. Also, here again the medium is air. So I will write Na here. Now, firstly, the light ray will enter in the air medium. It is coming from the air medium, so it will pass through this straight line. If this glass would not have been there, this ray of light would have passed like this, following this path. This was the original path of the incident ray PQ. Okay, but as soon as it is meeting the glass at this boundary, that is after point Q, the glass medium starts. So the medium is getting changed and hence there will be a refraction at this edge, that is AB, at point Q. So when a light ray PQ is incident along this normal, making an angle of incidence I, then it is entering from rare medium to the dense medium, and hence this light ray will deviate from its original path and bends towards this normal. Okay, this is the normal. Ray of light will bend towards the normal and follow this path. Okay, so this path is your refracted ray, and the angle between the normal and the refracted ray is given by R1. Okay, again the ray will go from glass to air medium after this edge CD. CD is your boundary for change in the medium. So at point R, this will be the incident ray, and after refraction, that is from denser medium to rarer medium, it should go from here, but it is going away from the normal. Why? Because it is entering from denser medium to rarer medium. So the final ray which will be emerging out will be this one, and this RS is known as your emergent ray. The emergent ray makes a certain angle with the normal, and this is your angle of emergence, whereas this is the normal and this is your incident ray for the second refraction. So it will be the angle of incidence which is known as R2. So there will be two refractions in the glass slab when the light ray is entering from air to glass, and then the light ray is going from glass to air. So there will be two refractions. So we will apply this Snell's law at 2 points. First is your air and glass in boundary, that is at point Q, and second is your glass and air boundary, that is at point R. So let's apply the Snell's law. Now the Snell's law says that the product of two things, that is refractive index of air medium with the angle of incidence I, that is Na multiplied by sine of I. This refractive index should be multiplied by this angle. is equal to refractive index of second medium, that is glass, multiplied by the second angle of refraction, that is R1, sin R1, sorry. So this will be your Snell's law. So now if I want to put it in simpler form, I will write it sin I divided by sin R1, which will be equal to Ng divided by Na, and this will be equation number 1. Again I am going to apply the Snell's law at point R. So at point R, the incidence angle will be R2 and the refractive index will be Ng. So I will write Ng sin of R2, which will be equal to, in the second medium, the refractive index is Na and the angle of refraction is E. So I will write sin E. So it will become sin of R2 upon sin of E, which will be equal to Na divided by Ng, and this will be your equation number 2. So from 1 and 2, what we will do, we will multiply both of them and see what happens. So let's multiply the left hand side and the right hand side. So on multiplying 1 by 2, let's see this. This is your left hand side, sin I divided by sin R1, sin I divided by sin R1, and I am going to multiply it with the left hand side of the second equation, that is sin R2 divided by sin of E. Okay? Then comes the right side, Ng divided by Na. Ng divided by Na will be multiplied by Na divided by Ng, and see what gets cancelled. Okay? So Na and Na gets cancelled, Ng and Ng gets cancelled. We will get 1 on the right hand side. Now come to the left hand side. We can see that there are two normals. One is this one and another is this one. These are two parallel lines and this is your transverse. So this will be the angle of our alternate angles, alternate interior angles. So these will be equal. So since R1 is equal to R2, because they are alternate interior angles, therefore sin of R1 will be equal to sin of R2, and hence we can cancel both of them, because one is in the denominator and another is in the numerator, and both of them are equal, so we can cancel it. So we will get finally sin I divided by sin E is equal to 1. Okay, so from here cross multiplying we will get sin I is equal to sin E. If we consider that the angles are very small, then we can see that I is equal to E. So here we can come to the conclusion that this angle of incidence will be equal to this angle of emergence. Now from this point we can conclude one more thing, that since I is equal to E, so these rays, that is PQ, will be parallel to RS. Why is it happening? So let's understand the reason behind it. So suppose this is a paper scale in which two sides are parallel to each other. Okay, I will draw this two side over here, one side, and let me draw the second side. This is the second side. Okay, and if I am going to draw the normal like this, so this will be the angle of incidence, and if I am drawing the another normal like this, so this will be the angle of emergence. This is angle of incidence and this is angle of emergence. So if I am saying that I is equal to E, okay, this will happen only when these two lines are parallel to each other. You can measure it with the help of protractor and see whether these angles are equal or not. If this angle is shifting towards the normal, then obviously this ray, that is emergent ray, will also shift towards the normal. So if this angle gets increased, then this angle will also get increased. Okay, so accordingly, if I is increased, then E will also get increased. You can see with the help of protractor. Okay, so we conclude that if I is equal to E, then this must be the conclusion that these two lines are parallel to each other. So from here we see that incident ray is parallel to emergent ray. What is the first conclusion? That incident ray is parallel to emergent ray. Okay, this is the first conclusion. And second conclusion is that if we see these two rays, then and we draw the perpendicular between them, then we will get the distance Rm, and Rm is the distance between the two parallel rays, that is incident ray and the emergent ray, and it will be known as lateral displacement. So lateral displacement is nothing but the sideways shifting is sideways shifting of incident ray when it passes through glass slab, and it is perpendicular distance between incident ray and emergent ray. So this will be the definition. Okay, so what you will say about the lateral displacement, that it is the perpendicular distance between the incident ray and the emergent ray. This is your incident ray, this is your emergent ray. The perpendicular distance between both of them will be known as lateral displacement. Now I come to the fact that what are the factors on which this lateral displacement depends. So there are three factors mainly on which this lateral displacement will depend. Let's discuss those. So factors affecting lateral displacement. First factor is angle of incidence. Angle of incidence. More is the angle of incidence, more will be the this perpendicular distance, or you can say lateral displacement. Second factor is thickness of the glass slab. Thickness of glass slab. More will be the thickness, more will be the lateral displacement. And lastly, the refractive index of glass. So these are the three factors on which the lateral displacement depends. I hope you have understood. Now let's come to the questions which were asked in the CBSE examination. So in the CBSE examination 2022, this question came: a ray of light is incident as shown. The diagram is given to you. This is your A medium, this is your B medium, and this is your C medium. This medium is rare, this medium is dense, and this medium is again rare. Now we have this normal. This is your incident ray. This is your refracted ray. Let this be angle 1. Let this be angle 2. This is your normal again, and then this is your emergent ray. This be angle of 3, this is angle 4. So it says if A, B and C are 3 different transparent media, then which of the following is true? पहला ऑप्शन है 1 is greater than 4, B option 1 is less than 2, and C option 3 is equal to 2, and D option 3 is greater than 4. These are the 4 options. So these are the 4 options for this question. Let's read the question again. इफ ए, बी एंड सी आर थ्री डिफरेंट ट्रांसपेरेंट मीडिया, मतलब ए मीडिया डिफरेंट है, बी मीडिया डिफरेंट है और सी मीडिया डिफरेंट है, ए और सी सेम नहीं है, ए और सी अलग अलग है, इसका रिफ्रैक्टिव इंडेक्स कुछ और होगा, इसका कुछ और होगा, पर है दोनों ही रेयर मीडियम, ठीक है। देन विच ऑफ द फॉलोइंग इज ट्रू, आपको बताना है कौन सा वाला ट्रू है। तो आप देख सकते हैं दिस इज एंगल 1, ओके, इट इज गोइंग फ्रॉम रेयर टू डेंस। जब भी कोई रे रेयर से डेंस जाती है तो जो एंगल ऑफ इंसिडेंस होता है वो ज्यादा होता है और एंगल ऑफ रिफ्रैक्शन होता है कम होता है। ये मैंने फर्स्ट लेक्चर में ही बता दिया था रिफ्रैक्टिव इंडेक्स के, ठीक है। इसके बाद आते हैं सेकंड और 3 में, ये नॉर्मल है, ये भी नॉर्मल है, ठीक है, दोनों नॉर्मल पैरेलल है, ये ट्रांसवर्स है, ये ऑल्टरनेट इंटीरियर एंगल है, अभी डिस्कस किया था 2 = 3, ये कंक्लूजन निकाल सकते हैं। अगेन दिस इज डेंस, दिस इज रेयर, डेंस से रेयर में जाने से एंगल जो है बढ़ जाता है, तो ये 3 जो है ये कम होगा और 4 क्या होगा, ज्यादा होगा। कम टू दिस 1 and 4, आपको साफ साफ देखने को मिल रहा है कि 1 में जो है, अभी हमने जो डिस्कशन किया था उसमें एंगल आई और एंगल ई बराबर था, लेकिन इसमें आप देख सकते हैं कि जो ई एंगल है ये बड़ा है, ठीक है। सो वी कैन से दैट 1 इज लेस एज कंपेयर टू 4। सो इनमें से ये हमारे कंक्लूजन्स हैं, इन कंक्लूजन्स को देख करके आप जो ऑप्शंस आपको सही लग रहे हैं उसको आप टिक कर लीजिए, ठीक है। तो आप देख सकते हैं 1 इज ग्रेटर देन 2, पर यहाँ पे 1 इज लेस देन 2, रॉन्ग है। 1 इज ग्रेटर देन 4, 1 इज लेस देन 4, ये रॉन्ग है। और 3 इज ग्रेटर देन 4, 3 शुड बी लेस देन 4, तो ये भी रॉन्ग है। 3 इज इक्वल टू 2, ये राइट है। तो ऑप्शन कौन सा हो गया आपका, सी ऑप्शन हो गया, ठीक है। तो दिस वाज द क्वेश्चन। नाउ लेट्स कम टू द अदर क्वेश्चन। So in the same year, a second question came, CBSE examination 2022. Let's write this question. So this question says, a ray of light starting from air passes medium A of refractive index 1.50 enters medium B of refractive index 1.33 and finally enters medium C of refractive index 2.42. If this ray emerges out in air from C, then for which of the following pairs of media the bending of light is least? So the options are air and medium 1, second option A medium, B medium, C option B and C, and D option C and air. The diagram is given in the question. The diagram is not given in the question. Just try to understand the question. It says that firstly the ray of light enters from air to A, ठीक है। पहले ray of light air से A में जाती है, फिर A से कहाँ जा रही है, B में जा रही है, फिर B से कहाँ जा रही है, C में जा रही है, और फिर C से कहाँ जा रही है, D में जा रही है। D मतलब air ही है। This ray emerges out in air, air में जा रही है, ठीक है। तो आपको बताना है कि इनमें से कौन सा पेयर ऐसा होगा जिसमें आपका मीडियम में बेंडिंग सबसे कम होगी, बेंडिंग ऑफ लाइट लीस्ट, ठीक है। इसमें एक कॉन्सेप्ट यूज करेंगे। कंसेप्ट ये है कि मोर इज द डिफरेंस, मोर विल बी द बेंडिंग, लेसर इज द डिफरेंस इन द रिफ्रैक्टिव इंडेक्स, लेसर विल बी द बेंडिंग। सो बेंडिंग ऑफ लाइट is directly proportional to difference in the refractive index of pairs of medium, ठीक है। तो इसका मतलब हमें पहले डिफरेंस निकालना पड़ेगा हर एक पेयर का। तो पहले ऑप्शन में देखते हैं रिफ्रैक्टिव इंडेक्स ऑफ एयर, डिफरेंस का साइन ये होता है, इसमें पता नहीं चलता कि कौन सा बड़ा है कौन सा छोटा है, बस हमें बस उसका माइनस साइन कंसिडर नहीं करना है और उसको एक्सट्रैक्ट कर देना है। तो एयर का रिफ्रैक्टिव इंडेक्स 1 और ए मीडियम का है 1.50, तो ये कितना आ जाएगा 0.50, उनका डिफरेंस आ गया। ऐसे ही सेकंड वाला देखिए Na Nb, इनमें देख लीजिए Na का है 1.50 डिफरेंस विथ Nb दैट इज 1.33, तो ये आ जाता है आपका 0.17। ऐसे ही Nb डिफरेंस Nc, ये आ जाएगा आपका 1.33 डिफरेंस 2.42, ये डिफरेंस आएगा आपका 1.09। और फिर लास्टली Nc डिफरेंस N एयर, ये डिफरेंस आएगा 2.42 माइनस 1.00 विच इज इक्वल टू 1.42. Okay, so out of all these four differences, whichever is the least will have the least bending. Okay, so let's compare them. So out of these 0.17 is the least, so second option will be your correct answer. Okay, so this was all about the previous year's questions, and more questions you can practice from different books. I hope आपको ये वीडियो अच्छी लगी होगी, and for more videos follow my channel Passion for Physics, like and subscribe. Thank you so much.